Hello, right now we're going to take notes 3. If you can please make sure in your notebook you have notes 3 at the top, and then it should say solving 1 and 2 step equations. I have 3 super secret strategies to help you solve 1 and 2 step equations. The first super secret strategy is that I want you to draw a line through the equal sign. An equation is two equal things. Whatever's on the left is equal to the right. If I add 5 pounds to the left, I have to add 5 pounds to the right. Everything always has to stay balanced. Whatever I do to one side, I have to do to the other. And so the line through the equal sign helps us have a visual break about where the left and the right side of the equation are. The second super secret strategy is to always try and get rid of subtractions. Subtractions and negatives are just, they get me down sometimes. And so my suggestion, remember when we do work with integers, we always add the opposite. We get rid of the subtraction sign by changing it to a plus sign and making the opposite of the number right after. I want you to try to do that with all subtraction signs in any equation and work with negatives instead of subtractions. And then my third super secret strategy is to get rid of the constant first. Remember, that's the number alone, and then to get rid of the coefficient. And then you can get your variable by itself. The whole point of solving equations is to get the variable on one side and move all the numbers to the other side. And in order to move the numbers, we're going to do the opposite of what the problem says. So if it says add 6, we're going to take away 6. Our goal is to make constants become a 0 and the coefficient to be a 1. Constants to be a 0, coefficients to be a 1. Those are my super secret strategies. We're going to do some examples. We're going to start with one step. One-step equations are called one-step equations because they have one number on the side of the equation with the variable. So again, my first strategy is to draw a line through the equal sign. So if you can write these down, that would be good. X plus 6 equals 12. Draw a line through the equal sign. That separates the equation into the two parts. My goal is to isolate, to get rid of everything with the x so that the x is by itself. Because if the x is by itself, I know what it has to be equal to. And so my job is to get the constant to go to 0 because x plus 0 is the same as x. That's the additive identity. To make a plus 6 go to 0, I'm going to take away 6. If I take away 6 from one side, I have to do the same thing to the other again. Remember, this is like a scale and we have to keep it balanced. These cancel and I'm left with x alone, and 12 minus 6 is 6. And so I have solved this equation. X is equal to 6. I could substitute that 6 back in. 6 plus 6, I'm telling you that x is 6, so I can rewrite this. Instead of writing an x, we can put a 6 here. 6 plus 6 equals 12, and so I know my equation is correct. Let's look at this next equation. I can draw a line through that equal sign again, separate the problem. And then I have a 10 times x equals 50. You might be able to do this in your head. This is saying 10 times what gives me 50. You might again be able to guess. But 10 and x are being multiplied, and so we're always going to do the inverse. The opposite or the inverse of multiplication is division. I'm going to make that coefficient be a 1 by dividing. 10 divided by 10 is 1. And so I'm left with just a 1x or x. And I have to divide the other side. Whatever I do to one side, I have to do to the other. 50 divided by 10 is 5. So that's my answer. This one looks confusing, but it's just division. The opposite of division is multiplication. So we're going to multiply both sides by 6. The 6's cancel, and x is equal to 54. If you plug that 54 in, 54 divided by 6 is 9. And for the last one, see how I'm still drawing that line through the equal sign? This is a minus 12. I don't like subtraction. I'm going to add the opposite. So remember to add the opposite. We make this addition. And then the second number becomes the opposite. The opposite of positive 12 is negative 12. My job again to get constants to go to 0. So if I have a negative 12, I'm below 0. If I'm on the number line, I need to add 12 to make it go up to 0. So I'm going to add